Now that you understand what machine learning is, let's look at two fundamental approaches: supervised learning and unsupervised learning. These aren't just technical distinctions, they represent different types of business problems you can solve. Let's start with supervised learning, because it's the most common and often the most immediately useful. In supervised learning, you train the model with labeled examples. Labeled means you already know the answer for each example in your training data. Here's a picture of a cat. The label says cat. Here's a picture of a dog. The label says dog. Here's a transaction. The label says fraud. Here's another transaction. The label says legitimate. The model studies these labeled examples and learns the relationship between the inputs and the correct outputs. Then, when you show it new, unlabeled data, it can predict the answer. Think of it like learning with a teacher. The teacher shows you examples and tells you the right answers. Over time, you learn to figure out the answers yourself. Supervised learning is incredibly powerful for prediction and classification problems. Will this customer churn? Is this email spam? What's the likely sales figure for next quarter? Does this medical image show signs of disease? If you have historical data where you know the outcomes, supervised learning can assist in predicting future outcomes. The catch, and this is important, is that you need those labels. Someone has to have identified which past transactions were fraudulent. Someone has to have diagnosed those medical images. Getting high-quality labeled data can be expensive and time-consuming. Sometimes it's the hardest part of the entire project. Now, let's look at unsupervised learning. In unsupervised learning, you don't have labels. You give the model data and essentially ask, what patterns can you find in here? The model explores the data on its own and discovers structure that wasn't explicitly defined. Think of it like learning without a teacher. You're exploring a new city without a guide. You start to notice patterns, like this area has lots of restaurants. That area is residential. There seems to be 3 distinct neighborhoods. Nobody told you this. You discovered it yourself. The most common use of unsupervised learning is clustering, meaning grouping familiar things together. Customer segmentation is a classic example. You might have data on thousands of customers, like their purchasing behavior, demographics, engagement patterns, but no predefined categories. Unsupervised learning can discover natural groupings. Perhaps there are 5 distinct customer types you never knew existed. Other uses include anomaly detection, finding unusual data points that don't fit any pattern, which could indicate fraud or equipment failure. It can also be used for dimensionality reduction, which means simplifying complex data while preserving its essential structure, which helps with visualization and further analysis. So how do you know which approach to use? Here's a simple framework. If you're trying to predict a specific outcome, like will this happen? What category is this? What's the likely value? And you have historical examples where you know the answer, use supervised learning. If you're trying to discover hidden structure like what groups exist in my data, what patterns am I missing, what's unusual, and you don't have predefined categories, use unsupervised learning. In practice, many real-world AI systems combine both approaches. You might use unsupervised learning to discover customer segments, then use supervised learning to predict which segment a new customer belongs to. Or you might use unsupervised anomaly detection as a first filter, then use supervised classification to categorize the anomalies. There's also a third category worth mentioning briefly: reinforcement learning. This is where a system learns by trial and error, receiving rewards or penalties based on its actions. It's how game-playing AIs learn to beat human champions, and is increasingly used in robotics and optimization problems. We won't go deep on it in this course, but know that it exists for problems where the goal is to learn a sequence of decisions, not just make single predictions. The key takeaway here is this: the type of problem you're trying to solve should determine the approach. When you're evaluating an AI proposal, ask what type of learning is being used and why. It's a good test of whether the team has thought carefully about the problem. Next, we'll look at how machines understand human language, natural language processing, and large language models, which is where some of the most dramatic recent progress has happened.